on this computer. All right. So 3.1.1 is where we're at, right? Strategies for solving equations. We're going to do the first 6 problems together. So there is a Desmos tool. You want to have your books open to your CPM ebooks to chapter 3. And I'll have to answer your question later, Grace. I don't know, you just use the add code to enroll again, but I can tell you how to do that later. All right. So for number 1 here, strategies for solving equations. We're going to look at how can we solve different types of equations, because we're going to solve more and more difficult types of equations. All right, so if you go to your CPM ebook, you're going to have the student e-tool that takes you to Desmos, and you would definitely want to use it, but not right at the second. So we're looking at how to solve like this equation right here. How many solutions does the equation y equals x plus 3 squared minus 5 have? Okay, how is this shown on a graph? So let's go ahead and write this down for 3.1. I need to annotate, and hopefully I have a good color. Let's use blue. Okay, so let's write the 3.1 here, and we're doing y equals x plus 3 squared minus 5. How many solutions does this have? How many x's and y's can we plug in here? Well, if we put it into Desmos, we're obviously going to get what kind of graph? We're going to get a parabola, right? So how many points are there on a parabola? Anybody? How many points do we have on a parabola? Feel free to unmute yourself or type it in the chat.
Don't we need 5 for the thing?
Well, you need 5 to get a good graph, right? But how many points are there actually on a parabola?
3.
There's only 3 points on a parabola?
Infinite amount, depending.
Okay, so let me get my drawing tool back. Okay, so if I pretend like this parabola is all drawn right here, there's only 3 points. There's only like this point and I don't know, this point and that point. That's it. There's just 3 points on a parabola. Or there's 5 points. Is there? So there's only 5 points on a parabola?
There's an infinite number of points.
Ah, how come there's an infinite number of points?
Because the graph keeps on going.
Because yeah, every point on the graph, every part, that's a point, 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 and it goes on forever. So there's points up here. So yeah, there's an infinite. So your answer to part A is there are infinite points, right? Excuse me, there are infinite points on a parabola. Just like on a line, there are infinite points. Why would a parabola be any different? It's a curved line. We just tend to only find 3 or to 5 of them to graph it, but there's an infinite amount, right? Because if we made a XY table, if I made an XY table, I could choose X to be anything. X could be -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, ... I could go on forever. I could pick as many points. I could pick 100 and there would be a point on this parabola. I could pick -100. There would be a point on that parabola. There's an infinite amount of points. There's infinite amount of, that means there's infinite solutions, right? So there's infinite solutions for a parabola. Okay, we tend to be only interested in 3 solutions on the parabola. Those 3 are definitely this point, the HK, the vertex, and usually we want to find our x-intercepts, some x0 and some other x0, right? Those are the 3 we care about, but there are way more solutions than just those 3. Okay. So I need to erase my writing here so we can read the rest of the problem. So I'm going to do that. All right, so for part B, how many solutions does the equation x plus 3 squared squared minus 5 equals 4 half. Okay, so we'll write that down. It's a little different than the last equation. What's the difference in this equation than the last equation?
The y value is changed to 4.
Good. We changed the y to a 4. So this y has now become a 4. So since we're limiting that, right? We're saying, hey, y equals 4, essentially. We're giving the y a value. So how many solutions on this parabola are there going to be when y equals 4? How many x solutions are we going to have? Do you think?
1.
1? Everybody agree with that? Anybody disagree with that? Or you guys think 1?
There's still an infinite amount of x solutions.
If we limit y to 4, y has to be 4. Y can't be 5, y can't be 6, y has to be 4. Okay, let's go to the
all you have to do is just solve for x.
yeah, so you have to solve for x. So there's only one solution for this quadratic. How many solutions does a quadratic How many solutions does a quadratic equation generally have? If you're solving a quadratic equation, using quadratic formula or factoring?
2.
Usually has 2 solutions. So this problem is going to have 2 solutions. Okay, let's see what those solutions are, because how is this shown on the graph? So to see what these solutions are, we're going to have to look at the graph. Okay, so I'm going to, hopefully whoever left is coming back, because I'm going to see how many minutes you're logged on when I log into my Zoom report. So I'm going to clear this away. I don't want to clear all of it away. I just want to clear, I'm going to clear this part right here. Okay, so if I click on my CPM book right here, right? I need to go to the lesson part. This is problem number 1 or 2. Let me stop my video. I don't need to put my video on. This is problem number 1. So if we click on this Desmos, whenever there's a Desmos tool, please use it. You know, they did a lot of work to make these. Okay, so here's our parabola. At 4, when y is equal to 4, that's way up here. So I'm going to go ahead and type an equation y equals 4 in here. Okay, and it's going to graph it for me. You see where y equals 4? There's 2 places where y equals 4. Those 2 places.
Do we need to graph this?
On Desmos, you do. So if you do a quick sketch, that would be nice. So our 2 solutions when y equals 4 is x equals -6 and x equals 0. Okay, so I'm going to write that on here. Get my pen back. X equals -6 and x equals 0, because our 2 points where y equals 4 is -6, 4 and 0, 4, right? That's when y equals 4 at both of these points. There's 2 solutions where y equals 4. That makes sense because it's a parabola and it comes down and comes back up. So there's 2 solutions. There's 2 times when y equals 4. Okay, so 2 solutions for this. Anytime we give them a y value, there's only one place when there's 1 solution, and that would be at the vertex. But if I pick this y value, if I pick y to be -2, those would be my 2 solutions. If I pick y to be 0, those would be my solutions. If I pick my y to be 2, those would be my solutions. Usually you're going to have 2 solutions. The only place you're only going to have 1 is at the vertex. Okay, every other one is going to have 2 solutions. Every other y value, unless we pick a y value down here, then we're going to have no solutions. Okay. All right. Once we pick something past -5, if I pick y equals -6, there's no solution. But at -5, there's 1 solution. Anything above -5 is going to have 2 solutions. All right. So that answers part B. So I need to clear this out and go back to the lesson page and look at C. Okay. Use the graph to solve the equation x plus 3 squared minus. So we solved it, right? That was the solution. What were the 2 solutions that we had? Let negative 6,
Negative
4,
6 and 0.
and 0, 4, right? Those are the two solutions. We found it on the graph, right? If you want to copy down the graph, awesome. If not, whatever. All right, so there are two solutions. We use the graph to find the solutions. Okay, the next part is going to ask us, well, we're not always going to have a graph. So how do we find the solutions if we don't have a graph, right? You're not always going to be on Desmos. You know, Desmos isn't always going to be right there. Okay, so I'm going to clear this. I'm going to go to the next slide, number 2. Okay, so now if we don't have an accurate graph, how do we solve them? Okay, so this is a different equation. So now we're going to make it equal to 11. I think it's the same problem, except now it's equal to 11. Okay, so they want us to solve this. Okay, so let's write this down. Get my pen back again, it keeps disappearing. So I'm going to put 3-2. I, number 1, is x plus 3 squared minus 5 equals 11. First step to solve this, what should we do? How about we add 5 to both sides, right? Solving for x, trying to get x by itself. So we're going to get x plus 3 squared equals 16. Okay, now I could get rid of the squared and I could get rid of the 3, or I could use what's called the look inside method. Okay, if you remember this from Math 1 or Math 2, I think definitely Math 1, we might have reviewed it in Math 2. If I look inside here, what number would I need to square to get 16, you guys? And is there one number, or is there only, so what number could I square to get 16?
4.
4.
Good, 4. So that tells me, so when I look inside, I can say the number inside needs to equal 4. So I can skip the squaring part and I could just say, hey, x plus 3 needs to equal 4. But actually there's another number that I could square to get 16 besides just 4. Who knows what that number is? The other number I could square is -4. Isn't -4 squared also 16? Right? So I need to, this number could inside could be +4, or x plus 3 could be -4. So we have two solutions, right? That makes sense. This is a parabola. It should have two solutions. So I'm going to -3 from this side to solve for our first solution. And get x equals 1 is our first solution. And it could also equal -4 that we're squaring. So I'm going to -3 from -4. So x is going to be -7. So those are my two solutions, 1 and -7. That makes sense because this is just a parabola that's been scooted over somewhere. And when y is 11, so that's the point like 1, 11. And this is the other point, negative, ooh, I did them backwards, -7, 11. Pretend those are backwards, okay? So those are our two solutions because it's a parabola. Okay, so that's the look inside method. Okay, let's see if we could do look inside for this one or not. So number 2, let's go ahead and copy it down. X plus 3 squared minus 5 equals 3. So again, this is called undoing right here because I need to undo this 5, right? So I'm going to add 5 first. So first we're going to undo the problem a little bit by one step. But x plus 3 squared equals 8. Okay. All right. So now I'm going to say, what can I square if I want to look inside again? What could I square to get 8? Oh, that's kind of, 8's not a perfect square, so that's harder, right? So maybe I want to undo some more. So maybe I want to take the square root to undo the squared and take the square root of this side and put a plus and minus there, right? So that's going to undo that squared. It's going to give me x plus 3 equals the positive and negative square root of 8. Okay, and it looks like I'm going to have to undo the 3 part too. So I'm going to -3 like that. Get x equals, and then we're going to put the real part and then the irrational part after. -3 plus or minus square root 8. Looks like it did when we did quadratic formula. If you use the quadratic formula, you will get this answer, right? Okay. but this is not in quadratic form, it's in graphing form, so it's easier to undo the 3 steps that we did. So this solution ended up being a little bit more complex than the last solution because these had just real numbers. Here we have an irrational number. So we just had to undo the 3 steps, and that's fine. We could do it that way. So those are 2 methods of solving equations, looking inside and undoing the problem. The other one is rewriting, and we're going to get to that next, rewriting the problem. Okay. So I have to erase this. If you need to take a picture of it real quick, go ahead, but I got to erase this. And next picture, next slide here. Okay, so these are the 3 steps that we have here. We have rewriting, looking inside, and undoing. Okay, that's basically the main thing. So let's use these 3 steps, maybe some of these 3 steps to solve this problem right here. So, so go ahead and write down the problem. X minus 5 over 4 plus 2/5 equals 9/10. Okay. We could like fraction bust. I can get rid of this 4, this 5, and this 10. What would I multiply by, you guys, to get rid of the 4, the 5, and the 10? Or what's the lowest common multiple of 4, 5, and 10? Lowest common multiple of 4, 5, and 10.
20.
20, right? Good. So we'd multiply by 20. So I'm going to multiply the whole problem by 20. And it says that's what Ernie decides to do. Ernie decides to multiply both sides of the equation by 20 so that his equation becomes, if I multiply by 20, this 4 is going to go into this 20 5 times. And then so we're going to get 5 times x minus 5, 5 times x minus 5. And then the 5 is going to go into the 24 times. So this 5 is going to go into 24 times. So we're going to have to multiply 4 times 2, which is 8. And then this 10 is going to go into this 22 times. So 2 times 9 is equal to 18. So that's what Ernie does here. He decides to multiply, and that's basically rewriting the problem. We rewrote it in a new form by multiplying by 20. Okay, so next L, so that is part A. Here's part B, see what L says. L takes Ernie's equation. He takes this equation and decides to subtract 8 from both sides. Well, if she subtracts 8 from both sides, which strategy is that? Is that rewriting, looking inside, or undoing? It's not looking inside, right? Is it rewriting or undoing? It's undoing, that's correct. So her strategy is undoing. So part B is undoing, right? She's undoing the 8, the addition of 8 by subtracting 8. So our next equation is 5 times x minus 5 equals 10, right? So that's what she gets right there, L. Next, part C, Eric looks at L's equation and says, I can tell that x minus 5 must equal 2. So he's looking at this part right here. He says, I know this has to be 2, right? Because 5 times something equals 10, right? What method is that?
Looking inside.
Right. So part C, Eric is looking inside. Looking inside. Okay. So we're saying, hey, this has to be 5 times 2 equals 10. So I just need to find what's inside. I need to find x minus 5 has to equal 2. So I could drop the 5 and the 10 part and just do the inside part. What's inside the parentheses has to equal 2. So my last step is I'm going to add 5. And I say x has to equal 7. So we used 3 steps. We used all 3 methods. First, we rewrote the problem. Then we undid the problem. Then we looked inside. So we used all 3 of these methods. Sometimes you can use all 3. Sometimes you can only use 1 or 2 of the methods. This problem, we happen to use all 3, okay, to get the answer x equals 7. All right, so we want to look to use these methods when we're solving equations. So I got to erase the screen here and move on to the next slide. Okay. So for this one, part 4, Graciela is trying to solve the equation x squared plus 2.5x minus 1.5 equals 0. I think we need to use the quadratic formula because of the decimals, she says to Walter. Walter replies, I'm sure there's another way. We don't have to use the quadratic formula. Can't we rewrite this equation so there aren't any decimals? Well, is that true? Can we do that? So 3-4, let's write the equation. X squared plus 2.5x minus 1.5 equals 0. Okay. That's our equation. It has 2 decimals in it. Is there a way to get rid of the decimals, you guys?
Multiply both sides by 2.
Oh, by 2. Yeah, I was just going to multiply by 10, but you could do 2. That is true. You could either multiply by 2 or 10. Okay, 2 would be a little easier. The reason I was going to say 10 is because that would move the decimal point over, that would move the decimal point, and that's going to move this decimal point. It'll be 10x squared, right? So you could do 10. Ethan says 2. I like it. Let's go with it. Let's multiply by 2 instead. Okay. 2 doesn't always work, but since these are 0.5, that's why 2 works. If this was a third, then you'd have to multiply by 3. If this was a sixth, then you'd multiply by 6, and so on and so forth. So when I multiply by 2, I get 2x squared. And then 2 times 2.5 is 5 plus 5x. And then what's 2 times 1.5, guys?
3.
3. And then 2 times 0, that's just going to stay 0, right? So now we have a quadratic. What's the fastest, easiest way to solve a quadratic? Factoring. We want to factor. So let's factor 2x squared. We're going to break that down to 2x times x. And then we factor the 3. The factor of 3 goes here and here. So the factor of 2x squared goes there and there. The factor of 3. So I can either put 3 and 1 or 1 and 3. Since it's a negative, I know the signs have to be different. And since there's a 5 inside, that tells me the 3 is going to be over here and the 1's going to be over here because I need this to be a 6x. That's why I know the 3 has to be over there because 2 times 3 is 6, right? That's 6x. And since I want a positive 5x, I want this to be positive, which means this is positive. And this will be negative because I need a -3, and a -1 times +3 is -3. Okay, so that's our factoring. I'm going to erase this little stuff at the bottom here and hopefully be able to get my pen back. Pen never comes back after I use the eraser. I think it's a bug. Okay, so we're going to set both of these equal to 0. 2x minus 1 equals 0. X plus 3 equals 0. Set both of our factors equal to 0 and solve our two solutions. Add 1, 2x equals 1, x equals 1/2 is our first solution. So we got a fraction, yay. Then we subtract 3 from both sides here. X equals -3. So if I were to graph this on Desmos, I would get 1/2 and -3 as our x-intercepts. Okay, that's how we solve that. We didn't need to use the quadratic formula, yay, because quadratic formula is kind of our last resort, right? The x equals -b plus or minus square root b squared minus 4ac all over 2a. That's last resort. You want to do that only if you have to. Okay. Rewrite it so that you can solve it without the quadratic formulas. Check in the graphing calculator. Okay, we're good. Those are the two solutions. So let's go to number 5. All right, I'm trying to get you out of here a little early. Okay, here's a lot of problems. I'm not going to do all these problems because I think you can do most of them. Which method would we use here? Rewrite, undo, or look inside? We are
Look inside, maybe.
Oh yeah, good. Yeah, look inside. We're going to do a few of them. So just write 3-5. I'm not going to do all 8 of them. But yeah, because 4 times what is 8, you guys?
Two.
2. So the absolute value has to be 2, right? But what other number could be in here besides 2?
-2.
Couldn't -2 be in there and that still be 8, right? Because it's an absolute value. So this could be +2 or -2. So by looking inside, I could say, hey, 8x minus 2 needs to equal +2, and 8x minus 2 needs to equal -2. And I'll let you guys solve that, and those are your two solutions, okay? How about this guy right here? Let's go ahead and write it down. B, 3 times the square root of 4x minus 8 plus 9 equals 15. What should I do first? Look inside, undo. What should I do first? There is something to look inside of, right? What can we look inside of? We can look inside the square root, but you want to do that last because there's other stuff we need to get rid of. So we need to undo a couple of things, right? What do we undo first, the 3 or the 9?
Nine.
Good, let's undo the 9. So we have 3 times the square root of 4x minus 8 equals 6. Okay. We can undo one more thing. You could say, oh, 3 times what is 6? We don't have to undo this 3, but we could.
2.
3 times 2, right? So this needs to equal 2. So let's undo the 3 just to clarify things here. I don't want to get confused there. So the square root of 4x minus 8, that equals 2. So what does the number underneath the square root need to equal? What square root equals 2?
4.
Okay, so square root of 4, right? So there needs to be a 4, not -4, just +4, right? So this 4x minus 8 equals, it has to equal 4 in order for this to be 2. So we could just set that equal to 4, the part that's underneath the square root, and then solve it. So let's do 2 steps to solve this. 4x equals 12, divide by 4, x equals 3. So we only got one solution for this problem. Why did we only get one solution? What kind of problem is this, you guys? Think pairing graph toolkit. It's a square root. It only has 1/2, right? So it doesn't come back on itself. It doesn't come back and do this. So there's only one solution for this problem. Okay, so x equals 3. When y equals 15, x equals 3. So we're going to have the point 315 on there, 3, 15. Okay, the other problems are very similar to what the last problems that I did. So I'm going to skip this whole section. You could do it if you need to. We could multiply by the LCM here, multiply by the LCM here, yada, yada. I'm going to skip to G and H here. Okay, so see if I can move this up a little bit. Clear all these drawings, get this away. I'm going to move these out of the way because I don't need them. I'm going to move G up here so I have more room. D over here. Whoops. D is going to disappear. We're going to do G and H. Okay, so let's see. Yeah, there's a reason why I wanted to do G, and because it comes out a little bit differently. So let's copy G. G is x minus 3 squared minus 2 equals -5. All right, what should we do first? We need to undo something. What should we undo?
The -2.
The -2. Okay, let's add 2. Good job. So x minus 3. Thank you for replying, guys. I love when you guys reply and I hear different voices. It makes me happy. It's like I'm not talking to myself and you guys are actually listening. I appreciate that. So -5 minus 2 is -3. Okay. Usually if I look inside here, what could I square to get -3? Well, first of all, when you square something, it becomes positive, right? So there's nothing you can square to get positive, but we did learn about imaginary numbers. So we actually can solve this. So let's just keep undoing the problem. Let's go ahead and take the square root take the square root of, and put a positive and negative out in front. And yes, we can take the square root of a negative number because we learned there's a thing as such as imaginary numbers. So this is going to be positive and negative I, imaginary number, times the root 3. So the negative underneath the square root becomes the I, the imaginary unit, right? We learned about that first semester. The imaginary unit is the square root of -1. Any negative will become an imaginary unit. You could drop the negative, put an I there for imaginary unit, and the 3 stays underneath the square root. Okay, so I have x minus 3 equals this positive negative imaginary unit times the square root of 3. Last step is we add a 3 to both sides. Okay, and our answer is going to look like a plus bi. If you remember that when we did imaginary units, this is a complex number where this is the real part and this is the imaginary part. We always put the imaginary part at the end and we put the real part first. Well, our real part is 3 and then plus and minus I root 3. So we have a complex answer. This is called a complex number. Okay, that is a complex number that we got. That you could get this using the quadratic formula too, but it's not in standard form, so we wouldn't want to use the quadratic formula. Okay, we got an imaginary answer. So this is why I wanted to do G, because we haven't done imaginary numbers in quite a while. Okay, H we need to do too. Last one on this section. And H is very similar to number 6, so it'll help us with number 6. And hopefully we're almost done. So x plus 2 squared plus 4 times x plus 2 minus 5 equals 0. I'll give you a second to copy that down. Now, there is kind of, can we like look inside, rewrite, undo? Any ideas on this one? Now I could multiply this all out, right? Like I could square this, I could multiply this out and then like have a big kind of messy thing over here that's equal to 0 and try to solve it. And that's the rewriting method, but that is kind of complicated. There's an easier way. Okay, so we're gonna do this. Oh, wow, it's raining. Okay. Okay, so so what if this x plus 2 wasn't x plus 2? And what if I replace it? Okay, this is called U substitution. What is U substitution? Substitution, hopefully I could spell. Okay, wouldn't this be a lot easier if you notice how this x plus 2 and that x plus 2 are the same? I'm gonna replace the x plus 2 with a different variable called u. Okay, and so this x plus 2, I'm going to make it u squared plus 4u minus 5 equals 0. Equals 0, like that. So this would be much easier to factor, right? This is just like, if this was an x, we could factor it really easy. So hey, let's just factor this, just like a normal problem. So I'm going to factor the u squared, that's u times u. I'm going to factor the 5, that's 1 times 5. And I need a positive 4, so this has to be a positive 5 and a negative 1 because I need a negative 5 when I multiply the negative 1 times 5. And we could solve for u here, right? Yeah, u would equal 1 and u would equal negative 5. Okay, but we don't want to stop here though, because we're not solving for u, we're solving for x. So now we're going to substitute this back in for u. I'm going to take, since u equals x plus 2, I'm going to substitute x plus 2 back here. So I'm going to substitute x plus 2 for this one. So x plus 2 equals 1. X plus 2 equals -5. So after I solved for u, I'm going to substitute the x back in because we actually want to solve for x. So now we're going to minus 2, x equals -1, minus 2, x equals -7. So this is how we use U substitution, okay? It's something you're going to use if you go on to pre-calc or calculus. So we just need to show it to you, okay? So that is, so if you have something complicated and you can simplify it, you can substitute it with U and then substitute it back in at the end to solve for it. So if you stop here and you say, oh, U equals 1, U equals -5, not quite right. We want to get to x equals -1, x equals -7. All right. So last problem, number 6 here. I'm going to clear this out. Okay. And next. Okay. So let's copy down 1 and 2 here. Okay. So 1 says x squared, or x squared plus 7x plus 12 equals 0. Okay. We could do this, right? We could just factor this, and that would be very easy to factor. X plus 3, x plus 4. I could see it. I could do it in my head. Okay. This, though, look how complicated this looks. Oh, we have to 1/2 x plus 7 squared plus 7 times 1/2 x plus 7 plus 12. How do I solve for x? Well, notice that these are the same, and we can use U substitution for them, right? So let's write the problem. I is 1/2 x plus 7 squared plus 7 times 1/2 x plus 7 plus 12 equals 0. Okay. Does anybody see that this is actually the exact same problem as this? Just instead of x's, right? Instead of it being an x squared, what do we have? 1/2 x.
1/2 x plus 7.
Exactly. That's right. Okay. So can't we make this problem like this by doing U substitution, right? So I'm going to let U equal the 1/2 x plus 7, right? Whatever's inside the parentheses, that's what you let U equal, what's in the parentheses. I'm going to replace that complicated thing in the parentheses with U squared plus 7U plus 12 equals 0. Now this looks much simpler. It's just like this problem. And I told you to factor this, this is just x plus 3 times x plus 4. So this is going to be U plus 3 times U plus 4. That is how you factor. That's how you get your 7 and your 12, right? You add 3 and 4 to get 7. You multiply 3 times 4 to get 12. So that's super easy to solve. So U is going to equal -3, and U, and you know what, we could put the U back in at this point right here. I kind of want to do that because I don't want you to solve, because you might think, oh, I'm done after I solve this. So let me do that. Let me undo this, and I'll go like this. I'm going to substitute the U back. If you want to do it the other way I did it, that's fine. But I'm going to put the U, I'm going to plug this back in for U over here. So 1/2 x plus 7, that's my U value, plus 3, because there's a plus 3 right here, equals 0, because I'm going to set this equal to 0, and then I'm going to set this equal to 0. And put the U back in again. 1/2 x plus 7 plus 4 equals 0, right? Because we would set both of these equal to 0. So that allows me to add these together. That's 10. So I get 1/2 x. Can I make it equal to -10 over here? Just move it to the other side, right? And then I'm going to multiply by 2, multiply by 2. So x equals -20 is my first solution, right? If I would have solved for U, I would have got U equals -3. Then I could put in the 1/2 x plus 7. I'll get -20. All right, so I'm going to solve this. This is 11. When I add these two together, I get plus 11. So I'm going to minus 11 to both sides. And I'm going to get 1/2 x equals -11. Then I'm going to multiply by 2, multiply by 2, and x equals -22. So that is our two solutions. So see, guys, this is called U substitution. When you get something complicated, like you're like, whoa, how do I solve? Don't multiply it all out. Just simplify it by using U substitution, by substituting these two things with a variable U so that it's very simple like this and it's easy to factor. All right. So, and that's what all this says over here, but we just did it like that. So that's the classwork. That's all you need to do for the classwork. You just need to submit this picture right now for 10 points credit for the classwork. So I know you were listening, you were taking notes, you hopefully paid attention to the lesson. I need to stop this recording here. Where's my record button?